The Chandrasekhar limit. What determines the fate of a star? This is the topic of discussion in today's lecture. So Chandrasekhar limit, the full name of that astrophysicist was Subramanian Chandrasekhar. He was an Indian-American astrophysicist and he was awarded Nobel Prize for his discovery about stellar structure and evolution. So what is this limit? Chandrasekhar limit. This is about a dying star. When a star exhausts its nuclear fuel, then what happens? It sheds its outer layers due to excessive gravitational pull in the core region, and the core region becomes a white dwarf. Now the question is whether the white dwarf will remain a white dwarf or it will transform into a neutron star or black hole. So these things can be decided by using the Chandrasekhar limit, and this is the discovery of Subramanian Chandrasekhar. Okay, the limit is 1.4. So what this number represents actually 1.4. This is the mass of the white dwarf divided by the mass of our sun. Okay, that means this is a ratio. So this is a dimensionless number, 1.4. So if the white dwarf of any star, okay, so if white dwarf is 1.4 or less than 1.4, that means if the mass of the white dwarf is 1.4 times the mass of the sun or less than that, then in that case the white dwarf remains a white dwarf. Okay, but if it crosses the limit 1.4, that means if the mass of the white dwarf is more than 1.4 times the mass of our sun, in that case there is a chance of transformation into either of the two. Either of the two means what? Either neutron star or a black hole. So if the limit is in between 1.4 and 3, okay, 1.4 and 3, then in that case the resulting structure is a neutron star. And if the limit crosses 3, means Chandrasekhar limit crosses 3, in that case the resulting structure is nothing but a black hole. So this is Chandrasekhar limit. The numerical value of Chandrasekhar limit is denoted as 1.4 because this 1.4, this number decides the fate of a star. Okay, so mass is calculated not with respect to the star but with respect to the white dwarf. So suppose there is a star and it is in the last stage, end stage of that star. End stage means when nuclear fuel is exhausted. When nuclear fuel is exhausted, in that case due to excessive gravitational pull, because outward pressure becomes zero when nuclear fuel exhausts. Okay, so in that case due to excessive gravitational pull, the outer layers, it sheds the outer layers and it becomes a white dwarf. Now in the white dwarf, what happens? Electrons are there. So due to electron degeneracy pressure, you know, Pauli's exclusion principle. Okay, so the combined effect of electron degeneracy pressure and Pauli's exclusion principle, the electrons start moving as close to the speed of light. Okay. And in that case, the electron degeneracy pressure becomes maximum. When this happens, when there is an excessive gravitational pull, but there is a limit because electrons have already reached to the highest speed. But after that, due to the limitation of speed of light, electrons cannot move faster. So in that case, electron degeneracy pressure fails to counterbalance the effect of gravitational pull. Okay, in that case there is a formation of neutron star or black hole. Now suppose already neutron star has formed. So in case of neutron star, so instead of electrons there are dominating role is played by neutrons. So neutron degeneracy pressure is there in case of neutron stars. And if neutron degeneracy pressure fails to counterbalance the effect of gravitational pull, in that case that becomes a black hole. And if the neutron degeneracy pressure can sustain the gravitational pull, then in that case it remains a neutron star. So this way fate of a dying star can be decided by using Chandrasekhar limit. Okay, and for this discovery he was awarded Nobel Prize, and he made this discovery at the age of only 19. But immediately he was not awarded with Nobel Prize. After a few years he was awarded with Nobel Prize after getting the experimental verification. Anyway, so this was all about today's topic, Chandrasekhar limit. Okay, so this is the end of this video. Thank you for watching this video.